Hi, today we are going to be solving logarithmic equations. So let's go ahead and get started. So problem A, we have logarithm base 8 of x equals 1/3. So the question is, how are we going to solve this bad boy? So our first goal in this case, because we only have one logarithm, and we are going to take our time and write this in exponential form. So let me go ahead and speak to myself. So write in exponential form. And the question is, now I have to remind myself, well, how are we going to write this in exponential form? So we can remember that if logarithm base b of x equals y, then b to the y equals x. I'm not even sure if I remembered that correctly because I don't memorize it like that. Instead, I prefer to remember it with words. So the question is, how do we go from logarithmic form to exponential form? And to do that, we are going to take the base, raise it to some power, and whatever that is, that should give us the argument. Okay, so we are going to look at our equation, identify the base, identify the power, and identify the argument. If we have those three ingredients, then we're on it. So in this case, I'm like, all right, what is the base of the logarithm? The base of the logarithm is 8, so we are going to start off by writing 8. Okay, so we have base to some power. Now the question is, well, what is the power? Well, in order to identify, we have to remember what a logarithm is. A logarithm is just code for exponent. So if a logarithm is an exponent, if the log equals 1/3, then the exponent is 1/3. So we have 8 to the 1/3 equals base to some power equals argument. So 8 to the 1/3 will give us the argument of x. And that's pretty much our answer. But the question is it simplified? I really don't know. So I'm going to assume that it's not until I realize that it is. So 8 to the 1/3, that's out of my comfort zone. So let's go ahead and write this in radical form. So since the denominator of the exponent is 3, then that means we have the cube root or third root of whatever we're left with, which is 8 raised to the first power. So we can put 8 to the first, or if you're cool like that, you can just omit the exponent of 1. And now the question is, well, what is the cube root of 8? So cube root of 8, I believe that's 2, but I don't trust myself. So let me just write 8 as a product of prime factors. I believe it's 2 to the third. And then with confidence, I'm like, oh yeah, index is 3, power is 3. So since they're the same, they undo each other. And that will leave us with the radicand of 2. So the moral of the story is that the solution is 2. Alright, so it's time for another fun problem. Let me go ahead and put this up. So we have problem B, and that reads logarithm base 49 of 1/7 equals x. And remember, we are asked to solve this equation. And this is like a funny equation for me because in order to solve an equation, any kind of equation, our ultimate goal is to isolate the variable. And last time I checked for this problem, the variable is isolated. So I kind of just want to punch this into my calculator. The problem is my calculator does not have a base 49 key. It has base 10 or base E. And since I forgot how the change of base rule works, then we're just going to go ahead and use the same strategy as before. And we're going to quickly write this in exponential form. Okay, so to write this in exponential form, so gentle reminder, it's base to some power equals the argument. So the base of the logarithm is 49. Base to some power, the log equals x. And since a log is just an exponent, the exponent is x equals 1/7. So now the question is, what kind of equation do I have now? In this case, the x is located in the exponent area, so we have an exponential equation. And now to remind myself, well, how do I solve exponential equations? So our ultimate goal is, it would be nice if we can fix it so both the left side and right side are written in terms of the base sense. This 7 caught my eye because I know that 49 is a power of 7. So let's go ahead and aim for base 7. Okay, so 49 in terms of base 7 or a power of 7, we are going to write that as 7 squared. And remember what's going on with the 49. The 49 is what's being raised to the x power. So let's go ahead and raise it to the x power. Now, I'm glad that we have a 7 on the right, but it's not in the right place. It should be in the numerator. So we are going to use the negative exponent rule in reverse to move the 7 to the other side of the fraction bar. Typically, we only use the negative exponent rule when we have a negative exponent, but we are going to use it in reverse. So we are going to go ahead, switch out the sign of the exponent. The current exponent is 1, so when we switch out the sign, that will give us -1. So at this point, I'm super pumped because we do have 7s on the board, but it's not quite base 7. Base on the left is 7 squared and not 7. So we're going to go ahead and use the power rule for exponents. So a gentle reminder, if we have a factor and we raise it to some power, how are we going to handle it? We're going to go ahead, keep the base and multiply the exponents. So when we have 7 squared and raise it to the x power, we are going to go ahead, keep the base and multiply the exponents. So we have 7 raised to the 2x is equal to 7 to the negative first power. Now at this point, I'm really pumped because our goal was to fix it so in terms of we have the same base, namely 7. So then at this point, how are we going to solve it? So we have to bear in mind the property of exponential equations. So the property of exponential equations states that if the bases are equal, there's no way around it. Then the powers have to be equal. So let's go ahead, set the exponents equal to each other. To finish it off, to isolate the variable, we'll divide both sides by 2, and that will give us x equals -1/2. All right, that was fun, but I think you guys have energy for 2 more. All right, so for the almost grand finale, let's go ahead and continue with problem C. So problem C reads logarithm base 9 of 27 equals x. And at a first glance, I wish this problem was on my test because the variable is already isolated. It's just a matter of simplifying logarithm base 9 of 27. And as I said before, we don't have a base 9 key. We just have a base 10 or base E key. And since I forgot how the change of base rule works, then we're going to use the same strategy. Let's go ahead and write this bad boy in exponential form. So a gentle reminder to write it in exponential form. We're going to write base to some power, and then that will give us the argument. So let's come to our problem. So the base of the logarithm in this case is 9. The power should be x because the log is just an exponent. So base to some power should give us the argument, and the argument is 27. All right, so once again, we have another exponential equation because the variable is in the exponent area. So now the question is, how are we going to handle it? It would be nice, and I say it's always nice because we're not guaranteed that we can fix it, so the bases are the same. In a later unit, we will see how are we going to handle it where we can't easily fix it, so the bases are the same. So in this case, I was thinking base 9, but 27 is not a power of 9. But if I keep my cool, 9 comes from a bunch of 3s. 27 also comes from a bunch of 3s. So why don't we go ahead and aim for base 3? So 9 in terms of base 3 or power of 3 will give us 3 squared. And then the question is, what was going on with the 9? We were squaring it. So let's go ahead, square our undercover 9. 27 is the same as 3 to the 3rd power. On the left side, we are going to apply the power rule for exponents. So power rule, we're going to keep the base and multiply the exponent. So that will give us 3 raised to the 2x is equal to 3 to the 3rd power. And at this point, I'm super pumped because we satisfied our initial goal. We wanted to fix it so the left side and right side are in terms of the same base, namely 3. So at this point, once again, let's apply the property of exponential equations, which means that if the bases are equal, then there's no way around it. Then the powers have to be equal. So that will give us 2x equals 3. And to wrap it up, after we divide both sides by 2, that will give us x equals 3/2. And that was a doozy. So that's pretty long, but I think you have the energy just for one more problem. Okay, let's go ahead and put problem D. So problem D, we have logarithm base 36 of the 4th root of 6 is equal to x. And we are asked to solve it. So in this case, the variable is already isolated, but I'm not sure how to enter this in my calculator. So we are going to just write this in exponential form. So we're going to take the base of the logarithm, which is 36. base to some power equals argument, the log equals x, so the exponent should equal x. Base to some power should give us the argument. And once again, you guessed it, we have another exponential equation because the variable is in the exponent. So it would be nice if we can fix it so the bases are the same. I noticed that 36 is a power of 6, and we have a 6 somewhere in there. So let's go ahead and aim for base 6. So when we write 36 in terms of base 6 or a power of 6, that will give us 6 squared. And what are we doing to the 36? It's being raised to the x power equals. I know we have a 6 on the right side, but we need to take it out of its cave. So let's go ahead and put this in exponential form. So to do that, we are going to keep the base or the radicand and then write the exponent as a fraction. And that will be current exponent divided by the index. Fantastic. When we apply the power rule to the left, power rule, raising powers, we're going to keep the base and multiply the exponents, and that will leave us with 6 raised to the 2x power equals 6 to the 1/4. At this point, I'm crying because it's like we nailed it. We totally nailed it. So once again, we'll apply the property of exponential equation, which means that if the bases are equal, then there's no way around it. Then the powers have to be equal. Hopefully you can read my writing. So we have that the left exponent equals the right exponent. And to isolate the variable, in this case, we usually divide both sides by 2, but me and fractions and division don't get along, so we're going to go the reciprocal route. So last time I checked, the product of any number and its reciprocal gives us 1, so this will allow us to isolate the variable. Quotient of 2 in itself will give us 1, so that will give us x equals 1/8. All right, that's my time. Thank you.